All right, so hopefully as you can see by the title of the slide, we're going to be working with slope-intercept form today. Should be a little background knowledge for you. We'll also do a quick background knowledge check on parallel and perpendicular lines to get started. And it should go pretty well for you today as long as you're paying attention. Remember, pause the video as you need. Make sure you're getting notes down. Make sure you're copying these examples down in so you're ready to go on Monday. Quick reminder on parallel and perpendicular lines. If I'm talking about parallel lines, I have lines that never touch, they never intersect, they go on forever in the same direction. And so clearly when we look at this, when we graph them, it's pretty easy to see. Whatever the slope of the black line is, it must be the same as the blue line. And so parallel lines, we know, have the exact same slope. That's a pretty simple one to pick up on, a pretty simple one to see. Perpendicular lines are a little trickier. We know perpendicular means they're going to intersect to form a 90-degree angle. As you look right here, we see that these two lines, the black and the blue line, cross to form a 90-degree angle. If you know anything about slope-intercept form, you can see that I have a slope of -4 and that I have a slope of 1/4. And so that tells us the tricky part about perpendicular lines. The slope of perpendicular lines are opposite reciprocals. If one was positive, the other is negative, and then we're flipping the fraction to get a reciprocal. So that's good, quick background knowledge check on parallel and perpendicular lines. Now into slope-intercept form. You see I have the graph of y equals 2x plus 3 shown. I want to look at this real quick and find that slope, that line's y-intercept and that line's slope. Clearly, if I look closely at the graph, I can see that that line crosses the y-axis at 3, so I know I have the y-intercept of 3. When I look at those points, I can see that I'm getting a rise of 2 each time and a run of 1. We're going up 2 over 1 each time, and so that gives me a 2 over 1 slope, which would be the slope of 2. I ask you, what do you notice about the equation of the line and the line slope-intercept? Well, so let's look at this. The equation of the line, here's a 2 and here's a 3. And so now we're seeing the slope-intercept form idea, that the slope and the y-intercepts are actually going to be shown in the equation when they're written in slope-intercept form. Reminder on what slope-intercept form looks like. It's y equals mx plus b. So one thing definitely notice right from the start, that it is solved for y. You have y equals the x term and then some constant. Notice m would be the slope of the line. M is the number directly in front of x. We would call that the coefficient of x, where b is the number that we are adding or subtracting from that term. So if we have an equation that is solved for y, that's written this way with the x term and then the constant term, it's written in y equals mx plus b form, we can use that to then identify the slope and the y-intercept right away just by looking at the equation. Giving a couple examples of this. If I have the equation y equals x minus 4, I should be able to find the slope and the y-intercept very quickly just by looking at this. First of all, to find the slope, or to find the m, I'm looking for the coefficient of x. And I know that if there's nothing written in front of x, this in this case would be understood to be 1. So this line has a slope of 1, or up 1 over 1. Then when I'm looking for the b, I see that we are subtracting 4 from that x term, so I would say that b equals a -4. Number 2 is a little trickier because we have an equation written in standard form, 3x plus 5y equals 10. In order to get it into slope-intercept form, I would definitely want to solve for y. And so my first step to do that would be to subtract 3x, but if I do that on one side, I must do that on the other. Watch very carefully how I order this. I would say this is 5y equals a -3x plus 10. I want to put that x term first, so it's mx plus b. Next step would be to divide by 5, and this is the tricky part. If I divide the first term by 5, I have to divide everything by 5. The 5's cancel out. I have y equals -3 over 5. I can just leave that as a fraction. That's -3/5 x plus 2. Now I know that the slope is a -3/5, and I know that the y-intercept is 2. The best thing about this slope-intercept form is used when we're graphing. We don't have to do tables. We don't have to do ordered pairs. We don't have to find x, y intercepts. We're just going to graph these. And notice this x, y intercept wouldn't be a very effective method anyway. Y equals x. Well, I need the m and I need the b. No number written, so again we understand the slope to be 1. And then what number would I be adding to this? Well, that'd be plus 0, so the y-intercept is 0. I start at the origin, I start at 0, and then I have a slope of 1. That means up 1 over 1, up 1 over 1 every time. If I want to get fancy, up 2 over 2 still puts me on that same line. Then I want to go back the other direction and make sure I get some negatives, really try to fill the page, and then I'm going to play connect the dots, and holy cow, that's the straightest line ever drawn in the history of a smartboard. You're watching a genius at work right here, people. I hope you're happy. Let me give you another example. Y equals 1/2 x minus 1. Again, identify the slope and identify the y-intercept. In this case, the coefficient of x is 1/2. The number that we are adding or subtracting, it's a -1. So I'm going to start down 1 on the y-axis. And now I'm using a slope of 1/2. And so again, think change in y over change in x. I'm going to be going up 1 over 2. Oops, excuse me. Up 1 over 2. up 1 over 2, up 1 over 2, and then the same thing in the other direction. I'll go down 1 and over 2 and down 1 and over 2. Should form a line, should form a spectacular straight line again. Holy cow, I'm on a roll. And now I've seen the line y equals 1/2 x minus 1 graphed. One last thing to look at based on what we talked about with parallel and perpendicular lines as well as slope-intercept form. We have the line y equals -3x, and I want the slope of a line that is parallel to that line and that is perpendicular to that line. So the first thing that I'm going to do is identify what the slope is of this original line so I can kind of get some ideas. And I can see this original line, y equals -3x, the coefficient of x is a -3. So this line has a negative slope, its slope is -3. Now I want to find the slope for each of these other lines to make them satisfy the given conditions. So the first one says I want a line that's parallel to that. Well, like we talked about at the beginning of the video, it's important to remember parallel lines have the exact same slope. And so when I'm working on this, if I want a parallel line to the original line, it has to have the exact same slope, which would be -3. Perpendicular is the one that's a little trickier, so I want you to pay attention to this. Perpendicular line slopes are opposite reciprocals of each other. Opposite reciprocals. Change the sign, flip the fraction. So in this case, we'll start with the original -3, and then first thing I would want to do is make it its opposite. The opposite of -3, of course, is 3. Then I want to think what the reciprocal of 3 is. Well, let's put 3 into a fraction, 3 over 1, and now we're going to flip that. That would become 1/3. And so if I wanted a line to be perpendicular to y equals -3x, it's going to have a slope of 1/3. That takes care of the new information for today. That's all you need to get into your notes today. But I would get excited for Monday when you come to class prepared to work on this. You can see the word problem that we will go through together on Monday. Apparently, Mr. Beeler has angered a ninja, and Mr. Beeler is about to be punished quite severely by the ninja. So while you're getting your notes ready and watching the video, you might also say a little prayer for Mr. Beeler and hope he doesn't get injured too bad by the ninja. See everybody on Monday.